This question asks us to simplify the expression, and we have three parentheses, and each parentheses has in it some algebra. We're going to call these monomials because it's like a polynomial, right, with numbers and letters, except there's only one little thing in each parentheses, so that's a monomial. And I'm just going to point out right at the top here, you could also choose to write this thing as negative 4x to the fifth inside a parentheses raised to the third power, because there are three of these identical parentheses. Now, they're not always identical, but in a case like this, you could shorthand it. That wouldn't be your answer, but it would be a nice little thing that I'm going to come back to at the end of the video. So what I'm going to do here is I'm going to multiply all the numbers together. So this becomes negative 4 times negative 4 times negative 4. Okay? And I'm also going to take those x to the fifth powers, and we're going to multiply those all together. But do you see how I'm kind of like dividing and conquering this problem? I'm taking my numbers separately from my letters and keeping them apart, and then we'll work on each and put them back together at the end. So negative times negative times negative, that's three negative signs. I'm not sure what the answer is, but that's definitely going to be a negative. And then if you think 4 times 4 times 4, well, that's kind of big. Let's see, 4 times 4 is 16, so this will be 64. It is fine if you want to use a calculator, especially as you get into double or triple digits. And then x to the fifth times x to the fifth times x to the fifth. Here is where sometimes people get a little uncomfortable, especially starting out. If you think about what each of those x to the fifths are, those are 5 x's, right? If I wanted, I could write it as x, 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 right? That's one of my x to the fifths. And then x, 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 x. That's another x to the fifth. And I might as well just go for broke, all three of them. There we go. So how many x's do you have being multiplied? There's 15 total if you count them all up, but no one writes it this way. That's kind of absurd. So we're going to say 64x to the 15th power. Now that's your answer. And stick around for another minute because I want to show you something a lot quicker than what I just did right here. Let's come back over to this side. If I think about this as an exponent in this case, I'm going to be multiplying this exponent, or distributing this exponent, better way of saying it, into the monomial. This doesn't always work, especially as your insides of the parentheses start turning into whole equations, but this is not a bad way to think about it. We've got negative 4 cubed and x to the fifth cubed. And now we get our negative 64 again. And in this case, I'm just going to multiply the exponents together because that is an exponent acting on another exponent, which multiplies them. Okay, that's x to the 15th. Now, as long as I've got you here, I might as well do another quick example because this isn't always going to look exactly the same in every parentheses. What if I just had another one like this, where it was, I don't know, negative 4x to the fifth times 3x to the seventh? Well, the first part is easy. We just multiply the negative 4 times the 3, that makes negative 12. And the next part, this is another rule about exponents. When you have exponents and they're in a multiplication problem, they add together. Okay, notice how neither of these is on the outside of a parentheses. It's not acting upon another exponent. They're simply being multiplied together in neighboring exponentials. So this becomes 5 plus 7 in that exponent power. And the result that you would get would be negative 12x to the 12th. Okay?